When purple octopuses from the distant future begin colonizing land within the pages of a book, rabbits evolve into long-legged antelope doppelgangers, and colossal descendants of buffalo roam a terraformed Mars. It's likely we're not dealing with potent illicit substances, but rather a literary creation belonging to a distinct genre known as speculative biology, also referred to as xenobiology. This unique genre emerges at the intersection of science fiction and biological principles. Before delving into xenobiology, it's crucial to establish a clear definition. When examining projects within this field, one invariably encounters detailed descriptions of organisms and the ecosystems they inhabit. We might learn about their physical characteristics, biological functions, and even their evolutionary lineage. These descriptions can be remarkably thorough and scientifically plausible. This then raises the question, can xenobiology truly be considered a science? Sadly, no. While the distinction might seem profound, like an insurmountable chasm, the reality is more nuanced, and this field holds far more depth than initially apparent. Science, by its nature, aims to comprehend the world around us. The theories and concepts proposed for explanation allow us to progressively extract verifiable facts from objective reality. Xenobiology, on the other hand, draws upon the theoretical framework of biology and other natural sciences, extending them onto a fantastical foundation, which is partly or entirely the product of the author's imagination. For the xenobiological genre, the foundational premise is the speculative scenario itself, where real biological processes and phenomena are made to operate. This could manifest as a future Earth, an alternative historical timeline, or the ecology of an alien planet ruled by a wise xenomorph. However, a mandatory condition is the strict adherence to scientific accuracy, even within the context of a fictional world, phenomenon, or creature. Throughout human history, exobiology has been influenced and shaped by individuals from various disciplines, including scientists, authors, and philosophers. Nevertheless, as a nascent field within biology, exobiology, astrobiology, and speculative biology continue to evolve and expand, leveraging significant advancements in related scientific domains, such as chemistry, as researchers explore the possibility of life arising from different chemical bases. Before we can hypothesize about non-protein based life in reality, not just in fiction, we must first understand what constitutes life itself. From a chemical perspective, life is essentially a complex reaction of organic molecules, and a catalyst is a substance that accelerates certain chemical processes without directly participating in them. For instance, the synthesis of chlorophyll is accelerated in the presence of iron. Chlorophyll itself acts as a catalyst in the photosynthesis of carbohydrates from water and carbon dioxide. If a molecule, when introduced into a solution containing the necessary reagents, triggers a chain of transformations that ultimately results in the creation of another identical molecule, we approach a fundamental characteristic of life. Substances, both organic and inorganic, possessing chemical properties and capable of reproduction under specific circumstances, are well understood by science. However, one cannot simply meld fur with fern, seasoned with acid, and expect a marvelous creature to emerge. Such an approach would be insufficient, and a new homunculus would not materialize. A molecule can only be deemed truly alive if an additional condition is met. It must be sufficiently complex for errors to occur during self replication. This leads to variation, and natural selection then comes into play. The more effectively a molecule can self replicate, perhaps by learning to utilize intermediate or byproduct chemical elements for the synthesis of necessary materials, the greater its number of copies with those same advantageous traits will become. And from there, the process becomes unstoppable. Thus, from a purely fabricated scientific concept, we transition into scientific fiction. Let us consider an illustrative example. We are all aware that carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur are the fundamental building blocks of life on Earth. However, the theory of xenobiology posits that in extraterrestrial environments, different elements might serve this role, enabling the construction of functional biomolecules essential for life. Silicon, for instance, with properties similar to carbon, is a promising candidate for the basis of alien life. Silicon, like carbon, exhibits a valence electron capacity for forming complex compounds necessary for life. Yet, considering the differences in chemical characteristics, silicon-based life would likely differ significantly from carbon-based life as we know it on Earth. Silicon is a heavier element than carbon, meaning silicon-based bonds would be larger and less stable at typical temperatures compared to carbon-based bonds. Furthermore, silicon readily bonds with oxygen, forming rigid crystalline structures instead of the flexible chains carbon forms, thereby limiting the diversity and adaptability observed in carbon-based life. Hypothetical silicon-based organisms might thrive in conditions inhospitable to carbon-based life, such as extreme heat or cold, as silicon can form more heat-resistant compounds. While science fiction often depicts silicon-based creatures resembling clay statues, from a scientific standpoint, the external differences between silicon hydrogen and protein-based beings could be minimal. Ammonia, much like water, is a polar molecule capable of dissolving a wide range of organic compounds and participating in diverse chemical reactions. The appearance of hypothetical life, forms based on ammonia, would largely depend on the specific environmental and evolutionary factors of their native world. Predicting their exact form remains highly speculative within our current scientific understanding. However, we can examine the properties of ammonia. Ammonia-based life forms could flourish in extremely cold environments where ammonia remains liquid due to its lower freezing point compared to water. This could influence their biochemistry, potentially leading to slower metabolic processes compared to Earth-based life. Their cellular biology might also differ substantially, as structures evolve to contain and isolate chemical reactions in an ammonia-rich environment could differ from the lipid bilayers observed in Earth organisms inhabiting water. Ammonia-based beings would likely possess a slow metabolism, leading to long lifespans, possibly even a happy existence, though their transformations would be gradual. Conversely, low temperatures would enable these creatures to absorb chemical substances that are too unstable at Earth temperatures. Ammonia-based life forms would likely seem unappealing due to their strong foul odor. However, this is somewhat irrelevant, as at Earth temperatures, these unfortunate beings would practically vaporize instantaneously. Interestingly, the concept of sulfur-based life also presents a rather plausible avenue for alternative existence. Sulfur is a crucial element in several terrestrial life processes, making its potential role in extraterrestrial biochemistry a credible consideration. The concept of sulfur based life suggests that such organisms could derive energy from the oxidation of sulfur or sulfur containing compounds, rendering them remarkably resilient compared to fragile humans. One of the most probable candidates within our solar system for sulfur based life is Jupiter's moon, Io. The intense volcanic activity on this satellite has resulted in significant sulfur deposits on its surface. Potential organisms inhabiting planets, or moons like Io, might breathe sulfur monoxide, which would function analogously to our oxygen. However, amidst extreme temperature fluctuations, the virtual absence of water, and intense Jovian radiation, life as we understand it would struggle to survive there. Though perhaps something akin to a fungus might still exist. The primary concern would be preventing it from boarding our spacecraft. Of course, not all inhabitants of fantastical realms would agree that life is solely a chemical phenomenon, and they would likely be correct. Classic science fiction literature mentions beings composed of magnetic fields, incandescent plasma, sentient oceans, or gas clouds drifting through space. A common characteristic of all non-chemical beings is their mysterious and likely artificial origin. An intelligent entity does not arise by chance. Complexity emerges from simplicity. Yet it remains unclear what would serve as the hereditary carrier in plasma blobs, or how a gas cloud or an ocean could undergo mutations and natural selection. Although we have yet to confirm extraterrestrial life, numerous discoveries, such as the presence of water on Mars, the existence of potentially habitable exoplanets, and organic molecules on comets, offer promising indications that life may exist elsewhere. Furthermore, continuous technological advancement steadily refines our methods of research and detection, fostering optimism regarding the possibility of discovering extraterrestrial life. As we press forward in our quest, we must remember the famous words of Carl Sagan. Imagination often transports us to worlds that never were, but without it, we cannot get anywhere. In this context, speculative biology is not merely discourse about life beyond Earth. Such a discipline cultivates our scientific imagination, thereby directing our pursuit of knowledge. In 1906, in the city of Plymouth, England, a peculiar experiment was conducted at a rural fair. Francis Galton, as an amusement for fairgoers, proposed an estimation of the weight of a bull put on public display, with participants writing their guesses on paper without revealing them. The organizers of the show promised prizes for correct answers, possibly a portion of the bull itself. Approximately 800 people participated in the voting. After collecting all the responses from the fair for analysis, Galton calculated the arithmetic mean, which came out to 542 kilograms and 900 grams. The actual weight of the bull turned out to be precisely 543 kilograms and 400 grams. In some unfathomable way, the diverse crowd provided an answer remarkably close to the real figure. In other words, the crowd's answer was more accurate than that of any single expert, such as a butcher or a cattle breeder. Galton, who previously believed in selection and the superiority of some individuals over others, was compelled to alter the direction of his research. As it turns out, under certain conditions, The collective intelligence of a large group of people is far more precise and reliable than the specialized knowledge of any single individual within that group. This phenomenon has been replicated numerous times across various fields. This concept, incidentally, is far from new. As early as 350 BCE, Aristotle wrote, "It is possible that many individuals, though not good in isolation, might be better when they gather together, not individually but collectively, just as communal meals, to which many contribute, are better than if provided by one person. That is, one head is good, but two are better. And if that's the case, then three heads are even better than two, and four even more so. With hundreds or thousands, reason is bound to prevail. What makes a crowd intelligent? Collective intelligence is based on two factors: diversity and independence. Often, a group of people comprising individuals from different professions, ages, and nationalities is smarter than a crowd composed of homogeneous individuals. Different people notice different details, and if properly integrated, the collective knowledge will be more extensive and detailed than the knowledge of any single person. Yes, collective intelligence, or intellect, is a concept introduced in the 1980s within sociology during the study of collective decision-making processes. Incidentally, collective intelligence is inherent in many animals, insects, and bacteria. There is even a concept called microbial intelligence, which views certain aspects of microorganism behavior as intelligence. This refers to complex adaptive behavior exhibited by individual cells, as well as cooperative behavior within populations of similar or dissimilar cells. In simpler terms, various protozoa or algae demonstrate remarkable self-organization abilities in changing circumstances. However, many more complex organized creatures also live in colonies, swarms, or even form temporary aggregations that appear to possess an independent intellect slightly exceeding the capabilities of individual members. While we perceive colonies as formations composed of individual organisms, each with its own interests and cognitive abilities, it is important not to forget that our own bodies, like those of every animal on the planet, are the product of numerous cooperative unions that arose under the pressure of circumstances. Developing this analogy, it is quite plausible to suggest that a single super-intelligent organism could emerge from the unification of many intelligent organisms, bound to each other so closely that they can no longer be considered separate entities. And here we arrive at the most fascinating part. We will now discuss the universe. Can we discern any hints of a cosmic superintelligence in space? It was previously believed that stars, galaxies, and all other cosmic matter were arranged chaotically in space. However, researchers have concluded that this is not the case. According to one theory, matter in the universe is not randomly distributed, but forms structural cells spanning from 100 to 300 million light years. An interesting pattern has been identified. Galaxies and their clusters are located along the walls of vast spatial honeycombs. The closer to the junctions of these cells, the more concentrated the matter becomes. A more thorough analysis of this discovery confirmed the cellular structure of the universe. The essence of this structure is that virtually all galaxies are situated within walls, forming hexagonal honeycombs. Let us hope we do not encounter galactic bees there. Within these cells themselves, there are virtually no galaxies. Instead, There are immense voids where not only our familiar matter is practically absent, but even rarefied matter, like interstellar and intergalactic gas, is scarce. Unfortunately, it is impossible to explain the structure of the universe based on our current understanding of physical laws. Yet, it is highly unlikely that such a structure could have formed randomly. If that is the case, we must search for a force that compelled galaxy clusters to group in this specific manner. It should be noted that hexagonal energetic constructions are not exclusive to the vast cosmos. They permeate many macro and microstructures of space. Hexagonal structures are frequently encountered in nature. Basalt columns from ancient volcanic eruptions, snowflakes, beehives, the eye structure of dragonflies, corals, crystals, and numerous other biological and non-biological structures possess a hexagonal form. If we consider non-biological examples, we can recall bubble foam and even the famously enormous hexagonal storm on Saturn. Why do hexagons appear so frequently in nature? It depends on the perspective. It could be an efficient method of conserving mass and energy, or simply a way to arrange atoms in a stable configuration. It could be purely a matter of geometry, or it might point to the existence of some form of cosmic supermind. This mind, it is theorized, created a stable hexagonal energy structure of space at a superfine level, where everything is governed by the harmonious laws of the universe. According to current understandings, the vast diversity of physical phenomena is reducible to four fundamental interactions: gravitational, electromagnetic, strong, and weak electromagnetic, and the nuclear weak and strong forces. All physical phenomena in our universe are described by equations containing fundamental constants. Among these are the speed of light, which sets the pace for the fastest processes, a constant defining the scale of quantum phenomena, the gravitational constant, and the masses, charges, and other parameters of elementary particles. What if we were to alter the strength of these fundamental interactions? For example, what if we slightly increase the nuclear interaction binding protons and neutrons? This would stabilize an atomic nucleus composed of two protons without neutrons, a so-called diproton, or helium-2. Calculations indicate that, in such a state, all protons would pair up, and no hydrogen would remain in the universe, thus precluding life. If gravity were intensified even a few times, stars would collapse and burn out tens of thousands of times faster, leaving no time for intelligent life to develop and sustain itself. If we were to weaken the strong interaction which binds protons and neutrons, atoms would become unstable. Weakening the weak interaction which governs neutrino behavior would prevent supernovae from exploding, thus halting the dispersal of heavy elements synthesized in stars throughout the cosmos, depriving us of planets. It appears that one cannot even slightly adjust the laws of physics without risking the creation of a universe devoid of observers. This peculiar fact has come to be known as the fine-tuning of our universe. But let us return to the spatial honeycombs, as it is possible they are somehow connected to the intelligence of our universe and its fine-tuning. One theory suggests that the matter filling these voids, being ultra-rarefied and ultra-energetic, possesses unusual, unknown properties. This matter may constitute the cosmic superintelligence that has existed within our universe from its inception. Thus, from its very birth, our universe was alive and sentient. Cosmic life hierarchically descends from mysterious matter within the voids of the intergalactic medium to galactic cores and plasma magnetic structures. It then extends through interstellar space to stars and finally to planets. Intelligent cosmic life creates according to its own design. What role does humanity play in all of this? If we delve a bit deeper into contemplation, as science is currently powerless in this regard, then according to cosmopsychism, the position that the universe as a whole possesses consciousness, humans and other conscious beings are aspects of this more fundamental superintelligence. It is often considered that the universe as a whole is the most fundamental entity, and all its various parts, stars, worlds, and ourselves, are in some sense derivatives of this more fundamental entirety. Will humanity ever develop its brain's capabilities to the extent of comprehending the universe and becoming part of this consciousness? Technical progress is the search for a unified theory of everything. It is likely that we have a long journey ahead before we can truly understand collective intelligence on scales as vast as our universe. When contemplating the scale of life within our known universe, we must consider aspects such as available resources, evolutionary strategies, mutations, and the physical limitations of planets and celestial bodies. Simply put, does an upper limit exist for the largest possible living organism in a scientifically rational world, excluding concepts like anti-gravity, magic, or other physical notions unknown to us? When we speak of life, we subconsciously refer to organisms ranging in size from cells and animals to fungi and trees. The largest creatures on Earth are record-holding animals that have achieved maximum parameters within their species in terms of mass, height, or length. For instance, the most robust gorillas after humans, naturally, are members of the great ape family, primates. Adult males can grow up to 2 meters tall. Their shoulders span 1 meter wide, and they can weigh 250 kilograms or more. It is advisable to avoid direct contact and naturally to share whatever you are holding in your hands or pockets. The elephant, the largest land mammal, can reach lengths of up to 7 meters and heights of up to 3.5 meters. An elephant's average body mass is up to 12 tons. Still, the blue whale reigns as the most enormous creature on Earth, both in mass and length, of all time. The blue whale's dimensions are truly astounding. These leviathans can extend up to 33 meters in length and weigh nearly 200 tons. The mythical kraken is not considered here. As you might have noticed, the most colossal animal on our planet resides in the water, even during the age of dinosaurs. This is no coincidence. The aquatic environment counteracts gravity, effectively reducing an object's weight several-fold. Even more significant is the cohesive force between the particles making up a body, which is dependent on gravity. The greater the gravity, the weaker this cohesive limit becomes. Marine creatures experience reduced weight, thus possessing a considerably greater particle cohesion limit. Furthermore, for large animals to inhabit land, they require a supporting structure. Terrestrial giants possess robust bony skeletons, developed limbs, and powerful musculature for this purpose. They expend considerable energy overcoming gravity and maneuvering their bodies, particularly on Mondays. However, let's consider amplifying a large creature tenfold. The skeleton's rigidity would increase by a maximum of 100-fold, while its mass would grow by 1,000-fold. Consequently, the skeleton would be incapable of supporting the body's weight, rendering the organism non-viable and as fragile as a biscuit. Disproportionate enlargement would also have a limited lifespan. If we were to stretch a living organism in a single dimension, the issue of metabolism would become paramount. Even trees have a limit to how high they can transport nutrients. This implies that as a planet grows and its gravitational pull intensifies, so does the force exerted on animal bones. Christian Huygens wrote about this as far back as the 15th century. But if gravity poses so many challenges, why not alter it by relocating to a smaller planet? This approach could work, but only up to a certain point. Planets cannot shrink indefinitely. The smallest planets would possess a mass 10 times less than Earth's. Consequently, the largest conceivable creatures would be at most 10 times larger than Earth's counterparts. Thus, on such a planet, we might encounter a malevolent gorilla roughly the size of a 5-story building. However, even these planets have minimal size requirements. If a planet's mass is less than 1/10 that of Earth, it cannot retain an atmosphere, a crucial condition for life. Therefore, our King Kong would not survive, even with a supply of colossal bananas. Of course, it's important to remember we're discussing organisms from Earth, which are, as we know, quite delicate. Hence, we will deviate slightly from the conventional terrestrial perspective and venture into science fiction. If planets are reasonably understood, let's consider space, where gravity is nearly absent. Imagine a life form resembling a colossal web, a jellyfish or a cosmic fungus, gathering interstellar dust for growth, utilizing starlight for both sustenance and propulsion via a biological light sail. To counteract gravity, such a creature would likely rotate as it grew, accumulating angular momentum and becoming ever larger. The organism's objective would be to balance gravitational forces with centrifugal acceleration. These beings could theoretically achieve colossal sizes, limited only by raw materials and solar energy. They might even infiltrate star systems, raiding planetary rings, asteroids, and even small moons like Vikings in search of resources, then departing the depleted area to continue their growth. Reproduction could occur by releasing spores, or more plausibly, by dividing into 2, 3, or more segments, akin to cellular division when they become excessively large. Would humanity simply become a meal? Most likely, yes, nothing more. What if we push this further, unshackling the organism from planetary life or even its orbit? It's conceivable that a hypothetical living entity could attain the dimensions of an entire star system, or even a galaxy. In such a scenario, however, even more challenges arise, primarily concerning energy and speed. Any creature must possess metabolism in some form. The exchange of nutrients between different parts of an organism is necessary for energy transfer. And to exchange this energy, it must first be acquired from somewhere. If our organism spans a star system, the only apparent energy source is a star. This leads us to a sort of living Dyson sphere. Metabolism would be exceptionally slow. Otherwise, substances would gain sufficient kinetic energy to escape the system. It remains unclear how such an organism could develop in the first place. Natural physical processes tend to form planets from the protoplanetary disk surrounding a star. If such an organism exists, it must resist this process, but how is unknown. If we consider intelligent life, an organism must develop information pathways. In humans, this is the interconnected network of neurons in the brain communicating via electrical impulses. However, scaling a brain model to the size of a solar system, let alone a galaxy, means neuron communication would still be limited by the speed of light. The speed of thought, the propagation of an impulse from one end of the brain to the other, would slow down trillions of times. In such a case, to think as many thoughts as a human does in a lifetime, the hypothetical creature would require a trillion times more time. It would need approximately 100 quadrillion years to think, a true philosopher on a cosmic scale. Yet, if a brain were the size of our galaxy, from its formation, there would only be enough time for 10,000 messages to traverse it from one end to the other. Therefore, it is quite difficult to envision life forms with complexity comparable to humans occupying scales significantly exceeding the size of a star. The next challenge we face is cooling. Yes, a living organism requires cooling. Computer chip designers constantly struggle with dissipating heat generated by computations. Living creatures face the same issue. While skin is responsible for cooling, heat is generated by volume, meaning larger animals cool less effectively. As far back as the 1930s, Swiss biologist Max Kleiber observed that for the vast majority of animals, the basal metabolic rate is proportional to their body mass. Indeed, if the rate of heating didn't decrease, large animals would simply cook. This might be convenient if you're in a hurry to prepare food. However, assuming that for a mammal's normal functioning, a minimum metabolic rate of 1/trillionth of a watt per nanogram is required, we arrive at a maximum organism size of around 1 million kilograms, less than 10 times the mass of a blue whale. It is possible, in principle, to imagine larger creatures by relying on the Landau principle, which describes the minimum energy necessary for computation, and assuming that the energy resources of a supermassive, slow-moving multicellular organism are solely dedicated to the gradual reproduction of its cells. Over time, we would observe that the problem of mechanical support surpasses issues of heat and water, becoming the primary limiting factor for growth. At such scales, however, it becomes unclear what such a creature would do or how it would originate. And of course, there is the notion that the universe itself is the largest living organism, possessing characteristics of a being constructed from information, considering metabolic processes, adaptation, and natural selection. The interpretation of the living universe hypothesis aligns with the cosmological view that it can transform into other universes. The universe also grows. It constantly expands and generates new galaxies. Eventually, it will cease to exist when it exhausts all its energy. If this is the case, a question arises: what are we doing within this organism? The thoughts on this matter are not very cheerful. Naturally, in broad circles, the idea of the universe as a living organism is considered more of a philosophical and even fantastical concept than a scientific one. However, our understanding of the universe continues to evolve. And as we make new discoveries in various fields, such as quantum mechanics, astrobiology, and cosmology, our perspective on the nature of the universe may change. In conclusion, it should be noted that the question of how large a living organism can be in a constantly expanding universe continues to spark interest and curiosity within the scientific community. While physical limitations like gravity and structural stability may constrain organism sizes on a biological level, the vastness of the universe presents infinite possibilities for life to flourish and develop beyond our imaginative boundaries. Who knows what incredible forms of life might exist in the depths of space, awaiting discovery? The possibilities are truly boundless. The imagery of UFOs and aliens frequently appears in science fiction. But what about reality? What are the chances of people encountering this phenomenon? In this episode, we will attempt to remain unbiased and address various questions and bold claims from those who have seen and know something. And at the end, I will share my own encounter with a UFO. We shall begin, perhaps, with the famous incident that occurred on July 4th, 1947. Farmer William Brazel went to check his flock of sheep after a severe thunderstorm. While doing so on a hillside in the desert, the farmer discovered strange debris from a mysterious object described as resembling a flying saucer. Furthermore, nearby lay transparent spheres within which humanoid figures could be discerned. The man reported this discovery to the sheriff. The military also arrived at the crash site. The story gained significant attention, and the news was even discussed on the local radio station. However, it was later reported that the find turned out to be a weather balloon, but most were not convinced. This incident was not recalled for 30 years, until the late 1970s, when intelligence chief Jesse Marcel admitted in an interview that the weather balloon story was a fabrication and that the military had indeed observed mysterious artifacts, such as unwrinkleable foil, strange symbols, and lightweight yet incredibly durable components. This story was discussed in the press for 2 decades. It concluded in 1994 with the publication of the official findings of a new investigation, which stated, "The object that crashed was part of a classified military program for monitoring nuclear tests." Well, the truth remains elusive. But this story has one strange coincidence, namely, the year of the event. It so happens that in the 1950s, an aircraft was created named the Avrokar. It bore a strong resemblance to a flying saucer, and these were not classified technologies. According to documents, engineers were attempting to achieve vertical landing and takeoff for the craft using jet engines. Specialists also believe their device could generally reach speeds of up to 5,000 kilometers per hour, ascend to altitudes of up to 30 kilometers, and have a maximum flight range of about 1,900 kilometers. In reality, however, experiments managed to lift the craft only a few meters, and its speed did not exceed 56 kilometers per hour. Due to its central jet engine, the flying apparatus operated loudly and subjected the pilot to high temperatures. The project was officially closed. But what if that's not the case? Just imagine what engineers could have achieved over 70 years. Meanwhile, unidentified flying objects continued to appear among both casual witnesses and pilots. For instance, in May 1957, fighter pilot Milton Torres, in a quiet English backwater, unexpectedly received orders to scramble and intercept an unidentified flying object. The pilot pursued the object, which at times appeared stationary, and then began to approach at a speed of about 2,000 kilometers per hour. According to the pilot, the UFO did not adhere to classical Newtonian mechanics. It made a sharp right turn almost on the spot, but when the pilot locked onto the object and prepared to fire, it vanished from radar screens. For your information, radar cannot detect ball lightning. This strange encounter was one of many that occurred during the Cold War. Generally, one of the most well-known UFO surveillance projects is the so-called Project Blue Book. Within this project, attempts were made to organize numerous eyewitness accounts into a unified archive. The project commenced in 1947, and all activities ceased by 1970. By the time of its closure, over 12,000 varied accounts of extraterrestrial life, UFOs, and aliens had been collected, the majority of which were mere fabrications and eyewitness hoaxes. But there were also events that remain inexplicable to this day. In the Soviet Union, matters were different. Special services actively investigated any reports of alien contact. Among ordinary people, there were many enthusiasts who dedicated their time to this issue voluntarily. In the 1990s, interest in UFOs waned, and with its disappearance, investigations also ceased, although archives of these phenomena, cases, and developments still exist. And now, in our time, specifically in 2022, NASA announced that it would undertake its own research into UFOs from a scientific perspective, or as they are now termed, unidentified anomalous phenomena or phenomena. This is not without reason. The frequent reports of suspicious objects in the skies over various countries have intensified since the United States began shooting down suspicious objects, including in Alaska, stating that it does not rule out extraterrestrial origins. But, as always, most of the materials are classified. Moreover, within a year, Uruguay, Chile, India, China, Canada, European countries, and especially countries experiencing military conflicts, reported strange objects in the sky, which also cannot be coincidental. So are these classified developments by large private corporations, or is it truly the intervention of alien travelers? David Grush, a former intelligence operative, has spoken in favor of the latter, asserting that authorities possess not only wreckage of alien spacecraft, but also alien remains. He is absolutely certain that authorities have been concealing top-secret programs for decades, aimed at detecting and studying extraterrestrial life forms and their technologies. According to him, there are partially undamaged aircraft of extraterrestrial origin that either landed successfully or crashed. Furthermore, he managed to obtain and begin studying fragments of UFOs within a classified government program for the search of alien craft. Alongside David Grush, two other witnesses, also Pentagon employees, testified similarly before a congressional committee. However, it's unclear why such top-secret information would be made available to the public if it were truly so confidential. Meanwhile, Professor of Immunology Gary Nolan stated that aliens have visited Earth and remain here to this day. In his opinion, the effect aliens have on Earthlings is the same as the impact of the Spanish galleons on the Native Americans of America. They simply cannot comprehend it. Additionally, footage was shown of two recently declassified UFO sighting cases. For example, a video taken in the Middle East in 2022. Another recording from South Asia, made this year, also awaits expert evaluation. However, reality might be more prosaic. After the incident with the Chinese balloon, people started looking more closely at the sky and, just in case, shooting down all objects within their field of view. News of mysterious objects shot down in the sky sparked a wave of activity among amateur ufologists, who predict that reports of UFOs will increase even more in the near future. And this is indeed the case. The U.S. intelligence community reported that as of August 2022, intelligence agencies received 510 reports of unidentified flying objects, which is a very high number. For comparison, prior to March 5th, 2021, only 344 reports of such objects were received in total over 17 years of observation. A particularly memorable incident from those times occurred in Belgium on the night of March 30th to 31st, 1990. That night, unknown objects were tracked on radar and observed by witnesses totaling approximately 13,000 people, of whom 2,600 submitted written statements with detailed descriptions of what they saw. Yes, it was impossible and pointless to hide such an event. Therefore, after the incident, the Belgian Air Force released a detailed report on the events of that night. Around 11 o'clock at night on March 30th, the head of the center received a report that 3 unusual lights were observed moving towards the city. The lights were reported to be brighter than stars, changing colors between red, green, and yellow, and positioned at the vertices of an equilateral triangle with a luminous element in its center. Approximately 10 minutes later, a second group of lights was detected, moving in the direction of the first triangle. After about half an hour, the phenomenon was observed on radar. At this time, the second group of lights, through some erratic maneuvers, also transformed into a small triangle. The command ordered 2 F-16 fighter jets to be dispatched under secrecy. Throughout this period, the phenomenon remained clearly visible from the ground. Witnesses described an entire formation of lights maintaining their relative positions while slowly traversing the sky. Over the next hour, 2 F-16 fighter jets attempted to lock onto the target 9 times. In 3 instances, radar coordinates were obtained for a few seconds. But each time, the target's position and speed changed so rapidly that the lock was lost. At the moment of the first radar focus, the target accelerated from 240 kilometers per hour to over 1,770 kilometers per hour, changing altitude from 2,700 meters to 1,500 meters, then to 3,150 meters, and then descended to near ground level. The initial descent of over 900 meters occurred in less than 2 seconds. Similar maneuvers were observed during both subsequent radar lock-ons. There were no indications of a sonic boom, which would have inevitably occurred when exceeding the sound barrier. Furthermore, according to eyewitness Robert Stagg, such sudden changes in acceleration and deceleration would have been fatal for one or more human pilots controlling the object. During this time, witnesses on the ground confirmed through a multitude of reports that the smaller triangle they observed had completely disappeared from view, while the large triangle ascended very rapidly as the F-16s flew past. Afterward, the aircraft radars and those at the control center completely lost contact. It's hard to believe, but it was precisely this object that I and several others observed in 2007, although it was in Russia, in a small town. The object was quite massive, about 30 meters, yet completely silent. It would hover and could instantaneously move in mere seconds. It looked exactly as described by witnesses in Belgium. To be honest, it was difficult to believe that this unidentified object was man-made. Most likely, you too have seen something strange in the sky. Share your story as well. Yes, people love intriguing mysteries, something mystical and inexplicable, and UFOs fall into this category. But there are nuances. An increased interest in the unexplained has a downside. This could fuel the mistaken belief that UFOs are alien spacecraft, acting as a smokescreen for governmental organizations and their machinations, especially given recent events. To support this, let us recall the unique, classified, and declassified projects that were already in existence by the 1950s. Just imagine, over 70 years have passed, and engineers could have achieved astounding advancements in a completely new field for us, one that we have no inkling about. Entirely novel technology, the very reason why silent craft of various shapes and sizes are able to fly. And it appears that these technologies will remain secret for a long time to come, because their integration into our lives threatens to disrupt numerous interests, ranging from national security to the global economy. But who knows? Perhaps we are mistaken, and someone has been watching over us for a very long time. We simply need to ascertain who or what exactly. In any case, the truth is out there. It is time to discover how legends are crafted in science fiction. So, welcome to the laboratory of a parallel universe. And today, we will take a closer look at the works of Olaf Stapledon, a British futurologist and writer, renowned for his contributions to science fiction, who created his outstanding works. As far back as the early 20th century, his writing style was characterized by its complexity and detail, while his prose was rich and poetic. Through this, he was able to paint such grand and vibrant pictures that they captured the reader's imagination, compelling them to ponder the inexplicable nature of the universe. The author was not merely a writer, he was a philosopher and a dreamer, living within his own fantastical world. For instance, the novel Star Maker stands as a monumental creation in the form of an intergalactic saga. Through it, countless diverse worlds unfold before the reader. The life cycles of planets, stars, galaxies, nebulae, our entire cosmos, and finally, the Star Maker himself and the procession of his creations are described. It is the story of an anonymous protagonist who unexpectedly discovers his consciousness adrift in the universe. He quickly realizes he can traverse time and space, and soon learns to control his flight. The narrator encounters beings akin to humans, with similar lives and struggles, and manages to form a connection with one of them. Before long, they both learn to leave their physical bodies and journey together. Gradually, they forge a collective consciousness, encompassing individuals from all the sentient species they encounter. They discover that through their shared mind, they can not only travel faster than light, but also move forward and backward through time. Such journeys grant them the ability to witness the very genesis of the universe, as well as its evolution and culmination. This allows them to observe the struggle for life across the cosmos. And struggle there is, as the wanderer's mental journeys initially lead them only to worlds that have experienced some form of crisis. Industrial society breeds class and national conflicts. Scientific advancement erodes old spiritual certainties, and ideologies of both individualism and collectivism rage. The narrator recounts various planets teeming with diverse life forms, including flora and colossal sentient vessels, and how they confront crises strikingly similar to those unfolding on Earth at the time. The collective mind learns to connect with more advanced civilizations. Ultimately, a symbiotic race of fish and aquatic arachnids emerges as the leading force, appearing to have mastered both the technological and spiritual realms. Their consciousness is purified of attachments and distractions, and they comprehend the interconnectedness of all things. After this, one might be tempted to investigate the capabilities of our own small fish in their aquarium. It turns out that at every stage of civilizational ascent, there are pitfalls. Technological catastrophe, or the allure of an interstellar empire, remarkably akin to the Great Filter hypothesis, later proposed by the British economist and futurologist Robin Hanson. Eventually, the collective consciousness bears witness to horrific wars that transform enlightened civilizations into warlike ones. As it transpires, even stars possess consciousness and fiercely resist manipulation by planetary powers, nearly causing a galactic catastrophe. Nebulae, too, are sentient. Everything is sentient, but technological progress, including telepathy, eventually eradicates war and ushers in a galactic utopia. Yet, for every sentient race that achieves galactic utopia, hundreds of others have approached it and perished, and millions more never managed to transcend their home planet. Energy is dwindling. The laws of thermodynamics are taking their toll. All galaxies in the cosmos will be unable to unite, reaching the final level. The energy of stars is depleting. Populations everywhere decline until they become too infinitesimal to sustain the unity of cosmic intelligence. Gradually, the clarity of universal consciousness fades. Eventually, it disintegrates, and the few remaining worlds subsist until the essential resources for life are completely exhausted. Then, life in the universe vanishes. Only lifeless and increasingly cooling matter remains. But this is by no means the end of everything. At the critical moment, cosmic intelligence comprehends the Star Maker, the entity who created the universe, and observes the dire plight of much of its creation, yet lacks the impetus to intervene and rectify the situation. Subsequently, returning to a human form, the narrator realizes that despite his insignificance compared to the inexplicable creation, he is nonetheless a part of it. Whatever power and opportunity he gains, no matter what happens, he must continue to press forward. The events of our lives may elevate us, but beneath it all we remain human, and that is our most crucial aspect. The narrator returns to his own life and continues to live it. He knows what will happen to Earth and our species. He knows it is not the happiest of stories, but he is nonetheless determined to play his part. Indeed, Olaf Stapledon was ahead of his time in many technical matters. The book's influence was quite extensive. Beyond inspiring a number of well-known authors, it is, to some extent, responsible for the science fiction concept of a large object known as a Dyson sphere. In fact, the novel presents a whole array of scientific concepts and philosophical reflections. For example, the evolution of intelligence. Here, the author explores the idea of evolution beyond Earth, envisioning various intelligent alien species, each possessing its unique biological characteristics. The concept of a galactic federation, featuring space settlements in the form of artificial hollow planets, though flat ones have yet to be observed. There are also conventional planets used as interstellar vessels, propelled by directed atomic explosions. The concept of a liquid-fueled rocket with a nuclear warhead, the idea of nuclear warfare employing atomic missiles, and interstellar wars between various intelligent civilizations, virtual reality, galactic colonization, the existence of planets in binary star systems. the concept of parallel worlds based on quantum theory, effectively predicted by Everett's many worlds interpretation. Some ideas here have become far more prevalent in later science fiction, particularly the notion that humanity and other life forms are moving towards some form of collective consciousness, a global, galactic, or even cosmic awareness that would represent a kind of utopia. Similar ideas can be found in Isaac Asimov's Foundation series and Stanisław Lem's Solaris. But perhaps one of the most significant metaphysical concepts in Star Maker is a powerful creative force or godlike figure that not only creates but constantly experiments and evolves the universe. All these bold and profound ideas helped Star Maker gain popularity among fans of the genre. This critically acclaimed book is more of a philosophical treatise on science, human nature, and the creator than a conventional novel. Stapledon's descriptions and socio philosophical musings on galactic empires, symbiotic and extraterrestrial life forms, genetic engineering, and overpopulation inspired a host of science fiction writers in the 1940s and 50s, including Arthur C. Clarke. In conclusion, it must be noted that Olaf Stapledon's Star Maker is a captivating exploration of cosmic ideas, effortlessly weaving together profound philosophy and science fiction. The novel distinguishes itself from other works in the genre not only through its ambitious narrative, spanning universes and millennia, but also through its thoughtful analysis of civilization, consciousness, and the nature of existence. Therefore, it comes highly recommended. This story compels contemplation, shatters paradoxical barriers, and spurs the expansion of our conceptions of the universe. It is more than science fiction. It is a treatise on existence, an exploration of the potential inherent in the universe, and ultimately, a guide to understanding our simultaneous cosmic insignificance and significance. Sciences such as astrobiology, exobiology, or xenobiology are dedicated to the study of hypothetical life forms that may have arisen and exist beyond our planet. Such extraterrestrial life could range from simple, single celled organisms with a single sucker to beings with advanced civilizations, possibly far more sophisticated than humanity. In one installment, we explored various search methodologies, including the Drake equation, designed to estimate the number of extraterrestrial civilizations in our galaxy, which is quite intriguing, and we will certainly revisit it in future episodes. However, today, we will remain within the confines of our solar system and examine what is currently known about life in all its manifestations on neighboring planets and their moons. So, let us commence our journey from the Sun to the outermost planet in our system. First, we encounter Mercury, the planet closest to the Sun, far too hot and far too cold on its opposite side from the star to sustain life. It may possess a tenuous oxygen atmosphere, but it is still critically insufficient to support and maintain any living organisms. But what if, deep beneath the surface, some forms of life, perhaps troglodytes, could exist? Yes, that is a possibility, but highly improbable on this planet. The issue is that the side of Mercury facing the Sun would be excessively hot, while the side facing away would be freezing, thus unable to sustain life. All creatures would face either a nightmarish inferno or eternal frost. Surviving under such prospects is challenging. Next is Venus, the second planet from the Sun. Its size and structure are comparable to Earth's. However, it possesses a crucial distinction. Its surface is hot enough to melt lead, let alone sustain living organisms. It has a crushingly dense atmosphere and active volcanic geology. Venus began its existence much like Earth, possibly even with oceans and all the potential for surface life. But the two planets took vastly different paths. An unchecked greenhouse effect likely vaporized Venus's oceans along with its inhabitants, transforming it into a planet-wide inferno, the hottest world in the solar system. It is a stark illustration of how terrestrial planets can burn. However, despite the harsh conditions for life, researchers have not entirely dismissed this planet. At an altitude of 50 to 60 kilometers, phosphine gas has been detected. Its concentration was low, only slightly higher than methane on Mars. But the fact of its detection is very difficult to dispute. Much has been written suggesting this could be a probable sign of life, with little green men literally floating in orbit. It is worth examining why. Firstly, phosphine is chemically reactive. It decomposes at elevated temperatures into pure phosphorus and hydrogen, the atoms of which it comprises. Secondly, in the conditions of Venusian clouds, phosphorus would simply fall downwards where no hydrogen exists. That is, from the locations where Earth telescopes detected it, phosphine should constantly vanish. Thirdly, and most importantly, on Earth, this gas, prior to the advent of humans, was formed exclusively through the activity of anaerobic bacteria. But how could they possibly exist in Venus's atmosphere? Could other civilizations have surpassed us and begun terraforming? That would be wonderful, but highly unlikely. Is it possible for phosphine to form through non-biological means? Yes, theoretically. Phosphine on Venus could be expelled by volcanoes and have no relation to life. Nevertheless, such a discovery is quite intriguing. Meanwhile, we set our course for Mars, another potentially habitable planet in the past, just like Venus and Earth. It resided within the star's habitable zone. In a way, the red planet tells a story mirroring Venus's, but from the opposite end of the temperature spectrum. Orbital and rover explorations on the surface confirm that Mars was once a watery world with rivers, lakes, and possibly even oceans. Subsequently, solar wind and radiation stripped away much of its atmosphere, and its minimal core activity ceased to generate a protective magnetic field. Mars's surface became prohibitively cold and dry. Has any life persisted on Mars? Excavations are needed. Perhaps we might find a space base, or at least the skeleton of a Martian or its pet, possibly beneath the surface or within the frozen polar caps. The primary challenges in the search for life are the scarcity of accessible water and the absence of plate tectonics, a process on Earth that shifts continents over epochs and transports buried nutrients back to the surface. Evidence of Martian life could include the detection of methane in the Martian atmosphere. On Earth, methane is replenished by the metabolic action of various life forms. Methane can also form from the reaction of water and rock, but subsurface microbial life remains another possibility that should not be dismissed. And how can we overlook the organic compounds discovered on the red planet by the Curiosity rover? Unfortunately, no Martian flounder. Here, both aliphatic and aromatic compounds were found, along with derivatives of thiophane, a cycle containing 4 carbon atoms and 1 sulfur atom. Why is this so significant? The reason is that on Earth, thiophanies can be found in coal and crude oil, products of biogenic origin. Moreover, They are produced by certain microbes and fungi. However, there remains a probability that the Martian molecules are abiotic in nature and formed through geochemical processes. Well, the future ExoMars mission might clarify the situation. A fundamentally important instrument for the future rover is a drill with a maximum working depth of up to 2 meters. At present, its launch has been postponed until at least the year 2024. Continuing our journey in search of life, we approach the majestic giants of the solar system: Jupiter, Saturn, Uranus, Neptune, and their retinue of moons can be considered nearly independent solar systems. And some of these satellites may well be inhabited worlds. For example, Europa, a moon of Jupiter with an icy crust that appears utterly lifeless. However, beneath the frozen surface, space probes have discovered evidence of a vast ocean of liquid water. Two other moons of Jupiter, Ganymede and Callisto, also likely harbor subsurface oceans, though they may be sandwiched between layers of ice, making life less probable. Europa, however, has good contact between its liquid water ocean and its rocky interior. This means mineral compounds are leached out, supplying resources for living organisms or alien killer whales, if they exist there, of course. Furthermore, traces of hydrogen peroxide have been detected, which is essential for methanogenesis, the formation of methane by anaerobic archaea. In addition to resources like peroxide, life also requires thermal energy, and that is likely present on Europa as well, thanks to which the inner layers shift and deform under gravitational influence. This results in friction, generating heat. Jupiter's moon's mantle heats up, warming the natural layers of the ocean. It is likely warmest at the poles. There, the maximum amount of heat should be generated, meaning something alive is definitely there. Since oxygen is very likely formed on Europa's surface under solar wind influence, and then enters the ocean through geological processes. True, the concentration of oxygen in the water is currently impossible to determine. As for life itself, it is believed that the food chain would be based on chemotrophic bacteria. They would form layers of organic deposits on the ocean floor, and other living organisms would feed on these deposits. These creatures are analogous to herbivores on Earth, much like vegans. Potentially habitable worlds can also be found among Saturn's moons. Enceladus, though tiny, also conceals an ocean of liquid water beneath its icy shell. This moon ejects free samples from its ocean into space without registration, like an SMS. And it is the only place in the solar system with guaranteed access to a subsurface ocean without needing to dig or drill wells in search of shells. So the Cassini probe, during its flyby, passed through such a plume. Unfortunately, it was not covered in algae, but it did find important clues for us. These include complex organic molecules, salts, similar to those found in Earth's oceans. For instance, silicate grains and other evidence of hydrothermal activity. The gases detected in the plume, hydrogen and methane, suggest sufficient energy to fuel life, making this object remarkably appealing. Approaching Titan, although it is small in size and has less gravity than Earth, Titan bears a resemblance to our own world. Nitrogen dominates this moon's atmosphere, much like Earth's. Titan is the only body in the solar system with rain, lakes, and rivers. Essentially, a complete hydrological cycle. Only its flowing bodies of water consist of hydrocarbons, methane, and ethane. A latex swimsuit would certainly not save us there. Titan also possesses a subsurface ocean of water, albeit deep down. And it is unknown whether this ocean interacts with anything on the surface. If it does, mixing with the complex chemistry on the surface could provide fuel for life. If not, there is another possibility. The chemical mixture on the surface could sustain life, as we do not yet know it, exotic forms, based on entirely different components and chemical reactions. However, the extreme cold on Titan's surface naturally means that chemistry proceeds very slowly. On a radio telescope in Australia, something has been detected regularly sending one pulse towards Earth. The signal repeats every hour, passing through 3 different states. The characteristics of the signal change mysteriously. Usually, the source of such a signal could be a neutron star or a white dwarf, but the signal's properties contradict the physics of these objects. How is this possible? A supermassive cosmic object, turbulent interference, or perhaps other civilizations are attempting to contact us. Let us try to understand by first examining the scientific aspect of this signal, and then the science fiction aspect. As is well known, beyond our atmosphere lies an incomprehensible silence. The absence of air capable of propagating sound waves transforms outer space into an absolute vacuum of sound. But besides sound waves, there are others that abundantly fill the cosmos: radio and electromagnetic waves, as well as X-rays and gamma radiation. Humanity intercepts them with antennas and then converts them into audible signals. In the vastness of space reside numerous enigmatic objects and phenomena, each possessing its unique voice. We've mastered the art of translating virtually any waves and vibrations into unique sonic signatures. Distant celestial bodies, brilliant stars, asteroids, black holes, pulsars, and even the bellowing calls of cowboys like Jimmy Barnes all communicate with us through their distinct musical voices, as if performing their own exclusive symphonies against the backdrop of infinite cosmic expanse. Periodically, we capture these extraterrestrial sounds, sometimes encountering something entirely novel. Today, we have just such an instance. The Australian Telescope Compact Array, or ASKAP, has detected a radio transient unlike any other. Its cycle spans nearly an hour, an extraordinary duration. At times, it emits long, brilliant bursts. At others, rapid, faint pulses, and occasionally, silence. The signal from the object designated G193 5+2 148 has captured the scientific community's attention due to its composition of circularly polarized radio waves, meaning the wave's orientation shifts as it traverses space. Human eyes cannot differentiate between circularly polarized light and unpolarized light. However, OSCAP functions akin to a pair of polarized sunglasses, filtering out glare from countless ordinary sources. Following the initial detection, astronomers conducted further observations. During this period, it was determined that this particular transient exhibits the slowest radio periodicity ever observed. To date, only 2 such objects have been discovered, and OSCAP's observed period of 53 minutes stands as the longest. But there's more. The object presents in 3 distinct states. In its first state, it emits bright, linearly polarized pulses lasting between 10 and 50 seconds. The second state reveals much fainter, circularly polarized pulses, with durations of approximately 370 milliseconds. The third state is quiescent, or dormant, with no detectable pulses. Researchers hypothesize that the object's varied modes and its transitions between them might stem from the interaction of complex magnetic fields and plasma streams originating from the source itself with the powerful magnetic fields present in the surrounding environment. The origin of a signal with such an extended cycle remains a profound enigma. The prime suspect? A slowly rotating cosmic entity. Perhaps not. A neutron star is a contender. However, the possibility of an Earth-sized white dwarf that has exhausted its energy cannot be ruled out. White dwarfs are known for their slow rotation periods, but it's unclear how they could generate radio signals of this nature. Another explanation suggests the object belongs to a binary system, where a neutron star or a white dwarf orbits an unseen companion star. Neutron stars are known to emit radio waves regularly, making them primary suspects. It's conceivable that such diverse signals could be produced by the interplay between powerful magnetic fields and intricate plasma flows. Yet a challenge arises. These objects typically rotate in seconds or fractions of a second per revolution. It is physically impossible for them to complete a single rotation in 54 minutes. This presents a significant puzzle, or to be frank, an astronomical impasse. Nevertheless, we must acknowledge that noise can vary in character, with different temporal scales of variability dominating. Consider the distinct sound of a cicada swarm versus the roar of ocean waves. Compare this to the noise patterns depicted in these illustrations. In case A, the characteristic variability times are shorter, indicating a prevalence of higher frequencies compared to case B. Because noise, as a process, evolves unpredictably over time, analyzing its frequency properties proves more advantageous. It is easier to identify dominant variability timescales than to predict the exact evolution of the noise process in the next moment. Technically, to investigate the frequency properties of a time-varying signal, a Fourier transform or harmonic analysis with varying frequencies is applied. On the other hand, white dwarfs would have no difficulty with such slow rotation, but it remains unexplained how they could generate the radio signals reaching Earth. This leads to an alternative, arguably unconventional, hypothesis regarding the signal's origin. What if it is artificial? Perhaps a coded message from another intelligent civilization. Before delving into that question, let's revisit a significant historical event. On August 15, 1977, the Big Ear radio telescope unexpectedly captured a signal composed of alphanumeric characters. It was immediately apparent to astronomers that they had encountered something extraordinary. At the time, the researcher circled the character groups with a pen and jotted down, "Wow," next to them. It truly seemed as if a signal had been received from the distant cosmos, and for years it was cited as evidence for the existence of extraterrestrial life. But what information did it contain? As one might surmise, the aliens did not exclaim, "Wow," themselves. They may not even possess mouths. The apparatus was designed to measure the ratio of signal strength to noise, meaning random interference. The numbers represented this measured ratio. Beyond 9, letters were employed, with A signifying a 10-fold excess, B an 11-fold excess, and so on. Consequently, the observed sequence represented a 72-second burst that appeared seemingly out of nowhere and never recurred. Due to the brevity of the spike, other instruments could not be used for confirmation, making it impossible to ascertain the source's distance. It could have been 10 kilometers, 100 astronomical units, or even 1,000 light years away. However, the direction was determined with remarkable precision. The signal emanated from the constellation Sagittarius, in a region near the Milky Way's core, an area of exceptionally high stellar density. Significantly later, researchers utilized the Gaia telescope's catalog and identified 15 potential star candidates that could have emitted the radio waves. The most promising among these was 2, MASSJ 1928, 1982, plus 21 48 23, situated approximately 1,800 light years away. Various radio telescopes have repeatedly attempted to detect the signal at the location where Big Ear registered it after 1977. The most recent effort occurred in 22, during which all 15 primary candidate sources were investigated. However, no sufficiently strong signal was received from any of them. Furthermore, there is no evidence of any exoplanets in that vicinity. Yet one aspect is clear. Some source of artificial radiation existed in the vicinity of the studied stars. If it were natural, we would have very likely heard it again by now, at least once more. This leads to the theory that the signal might have originated from a rapidly moving spacecraft. If that is the case, it could now be anywhere. Extraterrestrials, specifically the stereotypical green figures with large heads and tentacle-like legs. Why does this hypothesis warrant consideration? The reason lies in the fundamental principle of all digital communication systems: encoding. Without knowledge of the code, a message is not merely undecipherable, it is difficult to distinguish from noise. However, researchers posit that any code can be deciphered with sufficient data. A crucial piece of information is needed, much like how the British deciphered the German Enigma code during World War II. They deduced that each transmission contained meteorological data, implying the word weather would be present. By identifying this word, they cracked the cipher. In the context of extraterrestrial signals, such a key component could be navigational data. For interstellar travel, a convenient method for determining position is by using pulsar signals, which are consistently detectable and whose locations are well established. It is plausible, as the hypothesis authors suggest, that aliens might utilize these for pinpointing their spacecraft's location. If so, we could indeed obtain the necessary key to decode their messages. True, even the study's author acknowledges that we don't know how vastly different alien perceptions of the universe might be from our own. It's possible that the proposed method would be too complex for them to employ, or conversely too rudimentary. Regardless, we shouldn't rush to respond. Shouldn't. So does the signal originate from an unusual neutron star, an elusive white dwarf pulsar, or an extraterrestrial infant's coded message? We require more time to gather additional information about this peculiar and mysterious radio signal in the constellation Sagittarius. If intelligent life has flourished extensively within and beyond our galaxy, why have we observed no evidence of it? Several conventional explanations exist for this paradox. The first posits that life is indeed scarce and humanity is the first species to achieve a level of advancement sufficient to contemplate other civilizations. Another argument suggests that intelligent species were once widespread throughout history, but ultimately annihilated themselves or their environments through their own technologies, such as nuclear weapons or the burning of fossil fuels. A further perspective proposes that advanced civilizations are abundant and aware of our existence, but intentionally conceal themselves out of fear of disrupting our nascent culture. We have no compelling reason to believe that aliens have ever made contact with Earth. Certainly, conspiracy theories abound, but nothing concrete has emerged. However, physicist Enrico Fermi in 1950 proposed a hypothesis known as the Fermi paradox, which remains central to the search for extraterrestrial life and the concept of interstellar communication via signal transmission. Earth is estimated to be approximately 4.5 billion years old, with the emergence of primitive life dating back at least 3 billion years. The paradox asserts that given the vastness of the universe and the prevalence of favorable conditions for life, such circumstances have likely arisen numerous times. So, where are all the protagonists of these successful, or perhaps unsuccessful, civilizations? We have strong grounds to believe life should exist elsewhere, yet no response has been received. This predicament is central to the narrative of the novel The Three-Body Problem by the Chinese science fiction author Liu Cixin. Working in a radio observatory, the protagonist receives a message from an alien civilization claiming to be pacifists and warning against replying, lest Earth face an attack. Ultimately, the plot offers a detailed and elegant resolution to the Fermi paradox. The second book, The Dark Forest, elaborates on this. The universe is a forest, and each civilization is a hunter. Every civilization is an armed hunter, creeping through the trees like a ghost, cautiously parting the branches that obstruct their path, attempting to tread silently with the goal of possibly delivering a summons. In the end, everyone hides from each other. Disparities in technological progress prevent a stable balance of power, leaving the most rapidly advancing civilizations capable of eradicating all others. Over time, it becomes evident that in this perpetually threatening environment, those who excel at the game of survival persist the longest. We have joined a game that was underway before our arrival, and the strategy everyone has learned is to conceal oneself. None who understand the game would be foolish enough to contact anyone or respond to a message. The author depicts what he terms the worst possible universe. He does not assert that our universe is a true dark forest, where a single survival strategy, silence, and mortal danger prevails. The dark forest theory is sufficiently plausible to influence scientific discourse. Its potential impact is evident in the first contact protocols proposed by prominent astrobiologists Seth Shostak and John Trafton. Do nothing at first, they concluded, as any action could lead to catastrophe. In the event of alien contact, Earth should be notified via pre-established signals, not improvisations, and we must avoid any actions that could reveal information about our identity. In other words, firing a flare gun directly at an alien would not be the wisest course of action. The core principle is this: reciprocal messages would betray Earth's location. Again, Shostak and Trafton did not believe the dark forest theory to be accurate. Benevolent aliens might indeed exist. The point is simply that first contact would entail significant civilizational level risk. This contrasts with the assumptions prevalent in much Soviet-era Russian space literature, which posited that advanced civilizations would inevitably transcend conflict and thus exhibit a comradely disposition. For the most part, a scenario is created where a process of natural selection and competition for survival exists. However, we possess absolutely no evidence regarding the behavior of aliens or the dynamics of competition within or between other civilizations. These are largely speculative conjectures, even if we accept the notion that natural selection could operate at the group or even civilizational level. Beings evolve in interdependence, not isolation. Parasites depend on hosts. Flowers rely on birds for pollination. Every creature in the forest depends on insects. Interdependence does indeed lead to encounters that are repulsive, brutal, and fleeting, but it also takes other forms. This is how the forest operates in our world. Interestingly, the author of the books acknowledges this interdependence as a counterpoint to the dark forest theory. The audience and reader are constantly told that nothing in nature exists in isolation. There are many galaxies and potentially much life out there. In the author's narrative, this is used to explain why some individuals immediately side with the aliens. Yes, if you're unaware, the tickets are already sold out. And why is the desire to make contact so strong despite all the risks, especially this year? For this reason, the dark forest resolution to the Fermi paradox is unconvincing. The fact that we hear no one could equally indicate that they are too distant, or that the forest doesn't exist, and there's nothing more to listen to. This is why the predator civilization sounds like creatures at the apex of the food chain, consuming other living beings for energy, akin to a schoolchild at a fast food restaurant. If you clarify whom you are inquiring about, an answer might be available, but numerous other scenarios also address the question of their whereabouts. Predators that annihilate each other before achieving interstellar capabilities are conceivable, as is damage to a planet's biosphere. Numerous simulations offer potential answers. For instance, extraterrestrial entities might traverse galaxies so distant from the Milky Way that humanity currently lacks the technology to detect them. Another hypothesis suggests that aliens may have transitioned to a non-physical state, existing as pure mental beings in a dimension undetectable by our radio and optical sensors. A third scenario posits that a species might achieve galactic reach, but perish for reasons such as a gamma ray burst. Researcher Adrian Kent proposes another intriguing idea. Civilizations are abundant and have interacted many times in the past, but ultimately compete for scarce resources, much like humans vying for butter. When this occurs, the evolutionary process, acting over vast timescales, ensures that survivors learn to remain silent. And yes, this is logical. It is not an idea that can be easily dismissed. One counterargument might point to how evolution works on Earth, typically involving ecosystems where species become intricately interdependent. But evolution on a cosmic scale would be vastly different. It would operate across immense distances and habitable planets. The scarce resources would be exceedingly rare. That is, if cosmic habitats are sufficiently spread apart and difficult to detect. The best strategy for a typical species to avoid defeat in such competitions might be to avoid entering them by being as inconspicuous as a ninja, ensuring no potential adversary identifies their habitat as valuable. This raises critical questions about whether it is prudent for humanity to advertise its existence, essentially planting a giant poster that reads, "We are here." Various attempts to transmit messages to the stars have already been made, and many researchers have cautioned that this could be a grave error. However, I hasten to reassure you, as humanity is quite capable of managing without alien reapers. Nevertheless, the essence of the question can be summarized quite simply. If there are no aliens out there, then all efforts at communication have evidently been in vain. Thus, for the sake of discussion, we can assume that aliens do exist and will likely receive a message at some point, though probably not within our lifetime. It is often presumed that extraterrestrial life, capable of interstellar travel or communication, is abundant, as otherwise we would have already detected evidence of its existence. This, in turn, is sometimes interpreted as indirect evidence for the unlikelihood of life developing at all in our universe. One explanation is that life capable of manifesting on an interstellar scale has evolved in many places, but that evolutionary selection, operating on a cosmic scale, tends to eliminate species that openly reveal themselves and their habitats. Another reason is that, whatever the true situation, intelligent species may reasonably be concerned about potential dangers and thus tend toward caution. In part, this is a comforting idea because it suggests that we are still in a race for the most impressive and intelligent beings in the galaxy, and certainly faster than a snail. We haven't mastered interstellar travel yet, but beings that have are still working with technologies that can be disabled by a speck of dust. With a bit more targeted effort and a dash of reverse engineering, we could have our own interstellar armada ready before any alien civilizations decide to incinerate all life. But another curious hypothesis warrants consideration. Physicist Alexander Berezin of the National Research University of Electronic Technology in Moscow has proposed another potential solution to the paradox. While this conjecture shares similarities with others, namely the super-predator solution, it possesses a simplicity that renders it more logical and even appealing. The solution is first come, first served. It posits that the first life to achieve interstellar travel capability will inevitably eradicate all competition. However, unlike similar solutions that posit a destructive race acting out of fear, innate aggression, or malice, Berezin suggests that the eradicating life form acts out of ignorance. Yes, such behavior is characteristic of some humans. In this scenario, a cosmic civilization colonizes a planet and destroys existing life as an incidental consequence of its own expansion. They do this because they simply do not notice, much like a construction crew demolishes an anthill to build a sewer, because they have no incentive to protect it. His hypothesis would be accurate. The Fermi paradox finds its resolution in the principle of first in, last out, a concept that is straightforward, credible, and demands minimal conjecture, though this does not guarantee its accuracy. Theories positing fewer assumptions are frequently lauded, yet we continue to gaze skyward, contemplating our solitude, unless extraterrestrial neighbors opt for an appearance tomorrow. Crucially, let's hope they don't materialize in our immediate vicinity. Considering the significant time invested in dispatching humans to the moon and launching probes past Uranus, it is likely safe to surmise that any aliens reaching Earth would possess technologies far more inscrutable to us than a washing machine is to a beaver from Poland. The plausible scenarios are that we are either the sole sentient beings in the vast expanse, or that hyper-intelligent entities exist, yet we remain unaware of them for reasons previously articulated. Regardless, on a cosmic scale, our presence here is less than a fleeting moment. It seems improbable that some galactic apex predator would annihilate us all within the 80 years we inhabit this planet. However, should such an event transpire, it is even less probable that we would gain foreknowledge of it before its occurrence. Thus, no dramatic, effects laden conclusion. It is conceivable that we are entirely alone in the universe, save for a scattering of microbes, a prospect that would be profoundly disheartening, yet something we shall never ascertain.